integrals involving trigonometric functions, one needs to be able to recall various trig identities, and that can be quite overwhelming. In this video, I will show you how to reconstruct almost from scratch some of the most important trig identities. So let me very quickly list these trig identities. The first one is cosine of x plus y, which is equal to cosine of x times cosine of y minus sine of x times sine of y. The second one is sine of x plus y, which is equal to cosine of x times sine of y plus sine of x times cosine of y. The second one is the double angle formula, cosine of 2x, which is equal to cosine square of x minus sine square of x. And there are a couple of them. There's another double angle formula for the cosine function. Cosine of 2x is equal to 1 minus 2 sine square of x. And we also have cosine of 2x is equal to 2 cosine square of x minus 1. And finally, the double angle formula for sine of 2x, which is equal to 2 sine of x times cosine of x. Again, the purpose of this video is to show you how to reconstruct all of these formulas almost from scratch.
We'll also need to know a little bit about complex numbers. We'll need the following basic fact. First, the definition of a complex number. A complex number is simply a number of the type z equal to x plus iy. X is called the real part of z. Y is called the imaginary part of z. I is the non-real number called imaginary unit, which satisfies the equation I squared equal to -1. Now we'll also need to learn to remember the Euler formula. The Euler formula is stated as follows. Given E, which is the Euler number, e power ix is simply cosine of x plus I sine of x. So given a complex number of the type cosine of x plus I sine of x, this number can be conveniently written as EIX. And this is a very powerful formula, as we shall shortly see. Now I will show you how to use the Euler formula to derive these two trig identities. Let us start by considering the product EIX times EIY. Now using the Euler formula, we know that this will be equal to cosine of x plus I sine of x times cosine of y plus I sine of y. Now expanding this product, we'll obtain cosine of x times cosine of y plus I cosine of x sine of y plus I sine of x cosine of y. And now since I times I is I squared, which is -1, so we obtain here negative sine of x times sine of y. So after foiling this product, we obtain this complex number. Now we'll write this complex number in standard form. By standard form, we mean that we'll group all of the parts without the imaginary unit. So on one side we'll have cosine of x cosine of y minus sine of x sine of y, and on the other side we'll have plus I times cosine of x sine of y plus sine of x cosine of y. Now we'll again consider the same product EIX times EIY, and we'll write this as EI times x plus y. And appealing it again to the Euler formula, this is cosine of x plus y plus I sine x plus y. Now we have that EIX times EIY is equal to this complex number, and also EIX times EIY is also equal to cosine of x plus y plus I of sine of x plus y. So these two complex numbers are equal to each other. As such, the real part will be equal to each other, and the imaginary part will be equal to each other. So taking the real part of this complex number, we have cosine of x plus y is equal to cosine of x cosine of y minus sine of x sine of y, and this gives us one of the trig identities we were looking for. And for the last second one, we look at the imaginary part of this complex number, which is sine of x plus y, and this will be equal to the imaginary part of this complex number here, which is cosine of x sine of y plus sine of x cosine of y, giving us exactly the trig identities that we are looking for. Okay, now that we have established the trig identity cosine of x plus y is equal to cosine of x times cosine of y minus sine of x times sine of y, I'll show you how to exploit this trig identity to derive this double angle formula for cosine, namely cosine of 2x is equal to cosine square of x minus sine square of x. All right, so we will use this trig identity again for the cosine function, and then what we're going to do is the following. We will start with the left hand side of this identity that we want to derive, namely cosine of 2x, and I'm going to write cosine of x cosine of 2x as cosine of x plus x. Why? Because 2x is nothing but x plus x. So cosine of 2x is cosine of x plus x. Now I'm going to appeal to this trig identity here. Well, according to that trig identity, then this will be equal to cosine of x times cosine of x minus sine of x times sine of x. But cosine of x times itself is just cosine square of x, and sine of x times itself is just sine square of x, which is exactly what we want. Right, so now we have obtained the desired equality, which is that cosine of 2x is equal to cosine square of x minus sine square of x. To show you how to derive this double angle formula for the cosine function, namely cosine of 2x is equal to 1 minus 2 sine square of x. We'll need two ingredients here. First, the Pythagorean theorem, which is stated as cosine square of x plus sine square of x, which is equal to 1. And the second formula which we'll need, the second identity that we'll need, is the first double angle formula for the cosine function, which was established earlier, namely cosine of 2x is equal to cosine square of x minus sine square of x. Okay, let's get started. First, we know that the following must hold true. Since cosine square of x plus sine square of x is equal to 1, then we know that cosine square of x must be equal to 1 minus sine square of x. In fact, those two statements are equivalent to each other. Why? Because you can go from here to here and from here to there. So, knowing this fact, then we'll start with what we know, which is that cosine of 2x is equal to cosine square of x minus sine square of x. And then we are going to rewrite cosine square of x as 1 minus sine square of x. So we get that cosine square of x minus sine square of x is indeed equal to 1 minus 2 sine square of x, which is exactly what we want. So we have established the following trig identity. Cosine of 2x is equal to 1 minus 2 sine square of x. And this is the second double angle formula for the cosine function. Next, we will establish the third double angle formula for the cosine function, namely cosine of 2x is equal to 2 cosine square of x minus 1. We'll need to use these two trig identities, namely the Pythagorean theorem and the fact that cosine of 2x is equal to cosine square of x minus sine square of x, which was established earlier. Okay, let's get started. First, let's start with this fact which we know holds. We know that cosine 2x is equal to cosine square of x minus sine square of x. Now, using the Pythagorean theorem, we know that we can derive that sine square of x is, let me write this here on the side. We know that sine square of x is equal to 1 minus cosine square of x, and this is due to the Pythagorean theorem. So according to the Pythagorean theorem, we have that sine square of x is equal to 1 minus cosine square of x. Now I'm going to substitute that here. So we get that cosine of 2x is equal to cosine square of x minus 1 minus cosine square of x. Now, distributing the negative sign inside the parentheses, we'll obtain cosine square of x minus 1 plus cosine square of x. Now we can combine cosine square of x with cosine square of x. So we have two copies of cosine square of x, which gives us 2 cosine square of x minus 1. Therefore, we have derived that cosine of 2x is equal to 2 cosine square of x minus 1, which is exactly what we needed. Finally, I'm going to show you how to derive the double angle formula for the sine function, namely sine of 2x is 2 sine of x times cosine of x. So we know that we will need to use the fact that sine of x plus y is equal to cosine of x sine of x plus sine of x cosine of y, and this fact was established earlier too. So we will start with the fact that 2x is equal to x plus x. This allows us to say that sine of 2x is equal to sine of x plus x. Next, we'll appeal to this trig identity, and then we'll obtain cosine of x times sine of x plus sine of x times cosine of x. So sine of 2x is equal to cosine of x times sine of x plus sine of x times cosine of x. But notice that these two, we are adding two objects which are equal to each other, two expressions which are equal to each other. So we have two copies of cosine of x times sine of x. This gives us 2 cosine of x times sine of x, which is exactly what we want. Sine of 2x is equal to 2 cosine of x times sine of x. The double angle formula can be exploited for the purpose of power reduction, which is one of the most important techniques used to compute integrals involving trig functions. Now I'm going to show you very quickly how to reduce power. using these two double angle formula. Let's start with the first one. Considering the first double angle formula, cosine of 2x is equal to 1 minus 2 sine square of x, we can solve this for 2 sine square of x, and we get that 2 sine square of x is equal to 1 minus cosine of 2x. Next, we are going to divide each side of this equation by 2, and we get that sine square of x is equal to 1 minus cosine of 2x over 2, which then can be rewritten as half minus half cosine of 2x. Next, let's move on to the second double angle formula. Cosine of 2x is equal to 2 cosine square of x minus 1. Again, solving that equation for 2 cosine square of x, we get that 2 cosine square of x is equal to cosine of 2x plus 1. And then again, we are going to multiply each side of this equation by half, and we get cosine square of x is equal to cosine of 2x plus 1 over 2. Expanding this, we can rewrite it as half cosine of 2x plus half.